Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from domain of functions, right? So here we have to find the domain of this function f of x, which is the sum of inverse trigonometric function and the square root function, right? So here f of x is equal to sine inverse x plus square root of x minus 1 over 2, right? So we have to find all the values of x for which this function f of x is defined, right? So let us start. So let us take this function as g of x, and let us take this function as h of x, right? So here f of x is the sum of g of x, which is sine inverse x, and h of x, which is square root of x minus half. So whenever we have a function which is described as a sum of two functions, then to find out the domain of that function, which is f of x, what we do, we find the domain of this function g of x. So let us denote the domain of g of x, which is sine inverse x, as d1, and let us denote the domain of h of x as d2, right? And let us take the domain of f of x as d. So the domain of f of x is given by the common values of x, which satisfies sine inverse x and square root of x minus half simultaneously, right? So first we'll do or we'll find out the domain of this function, then we find out the domain of this function, and then we'll take the intersection of these two domains, right? So this is the concept behind finding out the domain of a function which is expressed as a sum of two or more functions. So now from the inverse trigonometric functions, we know that sine inverse x, it belongs to the interval that is from minus pi by 2 to pi by 2, right? And whenever this x belongs to this interval that is minus 1 to 1, right? So the domain of sine inverse x is given by this interval, which can also be written like this: x is greater than or equal to minus 1, but less than or equal to 1, right? So d1 is given by this inequality, right? Now let us find out d2. Now here we have the square root function, and anything which is inside the square root function has to be positive or equal to 0, because here x minus half should be greater than or equal to 0, because we cannot have a negative number inside the square root sign. So in that case, the number does not belong to the set of real numbers, right? So for x minus half to be positive, it should be greater than or equal to 0. So we can take x greater than or equal to half, right? So d2 is given by this inequality, and this inequality can also be expressed like this: x belongs to the interval that is half to infinity. So once we get the domains d1 and d2, the next step is to represent these domains on the real number line, right? So let us take this real number line. Here we have minus infinity, here we have plus infinity, here we have minus 1, then 0 and 1, right? And this 1 over 2, that is half, it lies between 0 and 1, right? So here we have half. So now d1 is from minus 1 to 1. So here we have d1, and including both these endpoints, right? So this is our d1, and d2 is given by this interval, that is half to infinity. So here we have half is included here, and we go like this, right? So this is our d2 from half to plus infinity. Now we have to identify the common region which is lying between these two domains, that is d1 and d2. And from this representation we can easily see that this region, that is from half to 1, right? So this part is common to both these domains, right? So d can now be written as from half to 1, right? So half is also included, and here 1 is also included, right? So the domain of this function f of x is given by this interval, and that is from half to 1, because this region is the only region which is common to both these domains, d1 and d2, right? Because this part that is from 1 to infinity is not included in d1, and similarly we can explain other regions also, right? So our required domain is given by this interval, which can also be written like this: x is greater than or equal to half but less than or equal to 1.